Let's do an example where we simplify an expression that has exponents. This kind of question came up a lot when I was working in a tutoring center, and a lot of students had problems with these. But once you break them down and do them in a step-by-step way, they're really quite doable. Let's take a look at an example. Here's our example. We want to simplify the square root of quantity y cubed x to the negative 1/2 times z all over z to the negative 1/3 times y to the 5th. This kind of example is very scary for students because there's a lot of stuff there. But let's rewrite it a little bit and see what we can do with our exponent rules. So first, I don't like that square root sign. Let's change it to a fractional exponent. Alright, so we changed that square root sign to a 1/2. Let's see what we can cancel out inside the parentheses before we apply that exponent. Alright, so we've got a y to the 3rd on top and a y to the 5th on bottom. The larger exponent is always going to eat the smaller one. So just as a little sidebar here, we've got, okay, here we go. We've got y cubed divided by y to the 5th, which is equal to y to the negative 2nd, which is equal to 1 over y squared. It's really easy to remember these by thinking that the larger exponent always eats the smaller one. Notice that the y to the 5th on bottom ate that y cubed and just became y to the 2nd. Alright, so let's change it in there. So we're reducing y cubed over y to the 5th, and this turns into x to the 1/2 z on top. Our y cubed is eaten by y to the 5th, which turns into y squared, like we just showed. And then we have z to the negative 1/3. And all this is to the 1/2. All right, so let's take this a little bit further. Let's reduce our z's. We've got a... All right, so let's take this a little bit further and reduce our z's. We've got z over z to the negative 1/3. Let's write it out over here. Here we are. We've got z divided by z to the negative 1/3. Using the division rule, this is z to the 1st minus negative 1/3. Remember, if you don't see a number for an exponent, that exponent is just 1. Anyway, so 1 minus negative 1/3, that's 1 plus 1/3, so we get z to the 4/3. This is just an application of the division rule. All right, so that means that over here, this is going to simplify as x to the negative 1/2 times z to the 4/3 over y squared, and this is all to the 1/2. Now it's good sometimes to do this little sidebar, because then you can tell, well, this has a positive exponent, so it's going to be in the numerator. And if it has a negative exponent, it's going to be in the denominator. So it kind of removes a little bit of the big confusion of looking at that and try to figuring out where things go. You can just do it piece by piece, and actually I recommend that for the first few times that you're going to simplify expressions like this. All right, looks like we've got one variable for each one, so we've reduced appropriately. Let's apply that exponent. When we take everything to the 1/2, we get that expression right there. 1/2 times negative 1/2 is negative 1/4. 1/2 times 4/3 is 4/6. And then 1/2 times 2 is just 1. So we're left with x to the negative 1/4 times z to the 4/6 divided by y. Now we need to simplify this a little bit more. For example, 4/6 is just 2/3. And we also need to get rid of that negative exponent. So let's rewrite it one more time. We're going to flip that x down to the denominator, like so. X to the negative 1/4 in the numerator is x to the 1/4 in the denominator. And lastly, that z to the 4/6, we're going to rewrite as z to the 2/3. Z to the 2/3 divided by x to the 1/4 times y. This expression, believe it or not, is the exact same thing as that. It took us a few steps to get there, but it is definitely the same expression. You might also see it expressed like this. The cube root of z squared divided by the 4th root of x times y. Again, these two things are equivalent. Just you need to get used to going back and forth between the notation of fractional exponents and actually writing the roots and powers in. All right, let's do one more example. All right, here's our example. 2x cubed y to the negative fifth times z, all to the negative 1/3. So what we're going to do first is we're going to take that negative 1/3 and run it through each term. By the way, you can do these problems in several different ways as long as you apply the exponent rules correctly. So you may find a different way or with different steps to arrive at the same answer. All right, let's take that negative 1/3 and apply it to each term. We get 2 to the negative 1/3 and x to the negative first and y to the positive 5/3, and lastly, z to the negative 1/3. So by the exponent rule, we just multiply that negative 1/3 by each exponent for each term. That's how we get our negative 1/3, negative 1, 5/3, and negative 1/3. All right, so let's get rid of these negative exponents. We're going to move some of this stuff to the denominator, and there you are. Now, if you're having problems with these, make sure that you practice adding and subtracting fractions, multiplying fractions together. Make sure that your basics are really concrete before you attempt doing these problems. Also, practice makes perfect. Try to do the same problems that I did in this video, except do it without looking at the answer and see if you get the same answer. Then, check out some problems from your textbook. All right, I hope this was helpful.